All right, this is lab 2-11, open line in a 3-wire circuit. The objective is to demonstrate the effect of an open line in a single-phase 3-wire circuit. The equipment is our bench. We got 2 cone heaters, and we have a 200-watt light bulb and a 60-watt light bulb connected up. We got a clamp-on meter over here, and then we got a multimeter which we can use. And then effectively we got a bunch of jumpers and stuff like that we've got connected up. So the purpose: when an open occurs in one of the line conductors of a single-phase 3-wire circuit, unusual voltage measurements may occur across the loads. By demonstrating the effect of an open line, it is hoped that you will be better equipped to recognize the symptoms of such a problem. One common way for which this situation may occur is when a single overcurrent device opens in this type of circuit. All right. So what they're asking us to do here is connect up a circuit the way that we're looking at it here. Make sure that the jumpers are long so we can get current measurements on it. Don't energize the circuit, because what they want is for us to calculate the following values. Now, from the drawing that's at the top of the page, I've connected it up appropriately. So that's the wiring diagram. However, in analyzing that, it can be a little bit difficult to see how I created the calculations for that. So what I've done is I've sort of simplified my calculations in a schematic type diagram here. Okay, so we've got the cone heaters in series across what I would hope would be 240 volts, but we know it's going to be less than that. And then we have a 60-watt light bulb coming from line 1 going back to neutral, and a 200-watt light bulb going from line 2 back to neutral. Okay, I've also estimated the currents based on the wattages that they would have output and the connected voltages that we would have liked to have seen. So in this case, we've got 6 amps leaving line 1. We've got 0.5 amps going down to that 60-watt bulb. We've got 5.5 amps heading out to the cone heaters. So that makes the 6 amps there. And then we've got 1.6 required for that 200-watt light bulb, leaving us with 7.1 coming back. So that means we've got the 6 plus the 1.1 leaving, 7.1 coming back. Now I know, based on our history within this school, that my voltages will not be 120. Therefore, these values that I've estimated are going to be wrong. However, I was doing that to sort of give you a little bit of an understanding on the way that this circuit is intended to work. Okay, and we will go over this in the Learning Hub as well. Okay, so what I'm going to do is, first off, I'm going to power my meters up to make sure that they're going to operate the way that they're intended. Okay, because they tend to go to sleep. All right, so we got AC amps, we got AC volts to measure our source. Lab power is on, so we can power up. And right off the bat, I had this left on because I tested this before. You can see my 200-watt light bulb is shining brightly. My 60-watt light bulb is shining brightly as well. You can't tell the cone heaters are on, but they will warm up, and I can tell you that they're certainly going to be working as well. Okay, so first thing that they ask us to do in this lab is energize the equipment, and then we're going to record the following voltage and current measurements. So the voltage from point 1 to point 2. So those are going across the cone heaters. Point 1 to point 2. You can see we've got 206 up there. So our voltage has fluctuated a bit again. Voltage across lamp 1. Lamp 1 being the 60-watt light bulb, lamp 1 is being the 200-watt light bulb. It's this guy here. So he is sitting at 102 roughly. Okay. And then light 2 is the 60-watt bulb over here. That's sitting at 104. Okay. So we've got a little bit of unbalanced voltage situation there. Okay. Next, they're going to ask us to measure the currents. Now we know this is unbalanced, so we're going to definitely see current on the neutral. Okay, so current in line A. So line A on the drawing was my line 1. Okay, and in this case it was actually feeding yeah, light number 2, that's right. So that's my line 1 here. So my current there is sitting at a little over 5 amps. 5.1. Okay, current in line B, so that's this guy here. He is 6 or 6.1. We'll call it 6.1. And that would mean that the current on the neutral should be the difference between the 6.1 and the 5.1, which should be very near 1 amp. And we're fluctuating to 0.9, roughly 0.9, so there's some rounding going on. We're going to call that 1 amp. Okay. Next, they ask us to de-energize the circuit and modify the circuit by removing jumper A. So jumper A is opening up line conductor 1. This one here. Okay. And in doing so, if we recall what happens if we lose our line 1, so now we've lost this guy, okay? This guy here, the line 2 to neutral, should still see the 103 or whatever it was, okay? But then all of this is going to add together to make roughly 103 or 104, okay? And then if we want to measure the voltage across the break, it would be the 208 or 206 or whatever, subtracting what those cone heater values were originally. And I think, what did I measure, 206 there? Or subtracting whatever the new value of that cone heater voltage drop would be. So let's power it up and see what happens here. So the lights are unaffected, roughly, or are they affected? Okay, our neutral's still connected up. However, we've lost line 1. Okay, so this light bulb is only glowing because it's got a different resistance compared to the cone heater, so it's seeing the bulk of the voltage drop across it. The cone heaters should see next to nothing across them. Okay, so the first thing that they're going to ask us to do is take some measurements. So measuring from point 1 to point 2. So point 1 to point 2, once again, was the voltage across my cone heaters. So that's here to here, and that is 15.81. We'll call it 16 volts. Voltage across lamp 1, which was the 200 watt, and that is sitting at 107. Roughly the same as what it was before. Okay, and if we looked at lamp 2, it should be the 103 or 104, subtract the 16. So that would be about 87-ish, somewhere around there. We're at 90, 91. Okay. And then they want to know the voltage across the open. So keep in mind, now if we've got 16 volts across the cone heaters, it should be my line to line, which is, now we're showing 220. That's the best we've ever gotten here. So we're going 220, subtract the 16. So that should be, what are we going to see? 204 roughly. So that should be my voltage across the break or across the open. Okay, so that'd be going from here to there. And we see 204 there. Okay, now we're going to look at current. We know current has changed from the original. Okay. All right, and we've got 1.7 on my line 1. And that means we definitely have to have 1.7 coming back on the neutral, because whatever leaves has to come back, and that's the case. Okay, then it says turn everything off, clean up my workstation, and then we'll talk in the virtual classroom about the results of this lab and the observations and conclusions, okay? So that was 2-11, opens in a 3-wire line, or a 3-wire circuit, okay? That's it.